Okay, so we ended the last video with me telling you to keep everything in the same folder, all the way from your original geometry files, which are imported into Workbench, and all the way to the simulation results and stuff like that. The reason for this is so you can, when you're done with your simulation, you can zip the folder up or move it to another hard drive or back up to a DVD or something like that. And when you put it back on your hard drive and open up the project, everything will be in place. So you can move the folder around, but if you move a single file from the folder and then try to open the project, it is going to tell you a bunch of stuff that you have missing files and stuff like that, and then you're going to have to change the paths to those files manually, and you would like to avoid that. So today we continue with the meshing. And there are several ways of doing this. As mentioned yesterday, we are just going to create a whole fluent flow because we're going to keep with these steps. We're going to share the geometry we prepared earlier. I can just confirm that the geometry is still the same. Okay, so here's our geometry. It's a single domain of air. You can see here under parts we have only one part, which is called air. Before we did a Boolean operation, we had two parts, which was our aim at body and the air domain. Now it's just air. Okay, so we're going to close that. And you can share the geometry by left-clicking on this one and holding, and just dragging the geometry. When it says share A2 field, you're just going to release. So geometry is now shared. You cannot change the geometry by clicking here and going to right-click edit, because it's going to be blacked out, because this is sharing the geometry from here. So if you want to change the geometry, click here and edit. Okay, we're going to go into our meshing application, which is ANSYS meshing, and it's kind of a almost fully automatic mesher that can do the job fairly quickly, and everything you want to do, you should first try in ANSYS meshing. If it can't be solved here, then you can move on to maybe ISMCFD or some other software for meshing. Okay, it's attaching the geometry now, and the first thing here on the right, you have meshing options. Usually if you just opened a meshing file, here's a mesh, if you double click this and then try to open a mesh, it would offer you these options for physics preference. Since we're doing a fluent flow, fluent case, which is a fluid flow, it already knows it's going to be CFD, so these are kind of blacked out and you cannot select them. You should leave this method as automatic, and this is all kind of okay, and just click OK. So now, before we go into any advanced stuff, we can just click generate or generate mesh or update, it's one and the same, and see what ANSYS meshing is going to do by default. So this is the mesh that it created by default. We can click our rotation tool here, left click anywhere to create the little rotational dot, and it's going to rotate our model about this point. Okay, so it obviously recognizes that there are some kind of curvatures here in the legs, and at the front of the model you can see the mesh is kind of slightly more refined here, but this is very coarse and it's just the first initial guess. Now we're going to go through the menu of ANSYS meshing one by one. So under sizing, this option here is advanced sizing functions. So obviously the pre-selected one was curvature. What you would like to put here in most cases is proximity and curvature. So it's going to refine the mesh based on proximity and on curvature. The relevant center, you can play with these settings, but there are three options. There's coarse, medium, and fine. And what these are, they're kind of pre-made kind of settings that can generally lower all the parameters. So watch this. If the relevant center is coarse, minimum size here for the face was 7 point something millimeters and 713, and the growth rate is 20%. So if we picked medium, you can see our kind of minimum sizes have dropped a bit. So this would yield a finer mesh. We can click update to check. and you can see already our mesh is kind of looking a bit more decent, but this is still way too coarse. So another option is to go under fine. Now this is going to kind of lower the minimum size a bit more and stuff like that, but you can also influence how much the relevance center is relevant by clicking here and dragging this kind of to, let's say, 100%. And now when we click back here, you can see it changed the curvature normal angle to 12 degrees, and so that's going to capture more geometric detail, and it dropped the minimum sizes a bit more. It dropped the default growth rate to 10%, and it's added a number of cells across a gap to be 5. Previously it was 3, so you can see over here we have kind of 3 elements in our gap between the road and the body. Now if we tried to generate one more mesh, we can see the result is kind of an even more refined and a better mesh, more suited for CFD, with 5 elements in the gap and a bit more controlled elements on the sides of our body. And you can see the default growth rate for the whole domain is now 10%, which is kind of it's very, very small, so you're more suited to use 20% growth. So what I usually like to do is leave this as default, and you can leave this one as it was coarse, and we're just going to change all of our settings here manually. So under smoothing, I'm going to go and put high. Initial seed size is basically where it is going to kind of try to do the mesh, and if you had more parts and stuff like that, it would be, you can choose the full assembly or active, or what parts are hidden and what are not. So smoothing high. Transition, slow and fast transition, I don't think they have any influence when we are doing the page conforming tetrahedron mesh. Only if you inserted a method and chose, okay, we would choose our body and we would say tetrahedrons and patch independent. This would kind of do the mesh in the ISM-CFD algorithm for octree mesh, and then the slow transition and the fast transition would differ, and you can check online and in the help files how the fast transition looks. But the slow transition is more suited to CFD because it fills the volume with elements a bit more smoothly and more proficiently. So we would leave this as slow, and span angle center can be left as fine. Now we can just drop this to 12, but for this kind of geometry it does not have any effect because it does not need any lower curvature normal angle than 18, but whatever, we're going to leave this here. So the number of cells across gap, let's leave that as 5. The minimum size, we can put 1 millimeter, even though it probably will not put 1 millimeter elements anywhere on the body. Maximum face size, we're going to put, let's say, 250 millimeters here, and same here, because these two kind of they're set. If we put them back to defaults, you can see that this one is kind of 2 times larger than this one, but if you try to change all of these manually, you will see that there is no effect if they're put in as different values, that they're going to depend on the maximum face size. So just put 250 here and 250 here. Basically always change both of them so they remain the same number. And the growth rate can be 1.2, just fix that in. It can also provide you with a minimum edge length on your body. And this is kind of it as far as the sizing goes. So we can try to update our mesh once more. I'm just going to zoom out a bit so we can see the effect on the domain. Okay, and update. Okay, and here is how the mesh looks with our settings. So we can see that we still have a kind of a enough cells in the gap between the road and the body, and the surface mesh is looking okay, but these elements are still too large for our needs. So, but you can see it's not wasting the elements on the domain. We've limited it to 250 millimeters, and this is kind of okay for the far field. So what we would like to do now is put in some size limits on the elements for the surfaces of the body. So what we can do is go to right click on mesh, insert, and sizing. And now you can size several things. You can do a body sizing, an edge sizing, and a face sizing. So what we would like to do is, let's say on our little legs here, we would like to have a kind of a more fine mesh. So we're going to limit the element size here to 2 millimeters, okay? And another thing that we're going to do is insert another sizing, and let's say for all of our surfaces of the body, just hold the control key down and click all of these, okay? We're going to limit the element size to, let's say, 10 millimeters. Now this soft behavior, we're going to explain it a bit later, but if you okay, I'm just going to generate the mesh and then explain, because it will be more graphic. Okay, the mesh is done, and we have a warning here saying the default defeaturing tolerance was larger than one computed based on size controls. What this means is you have a defeaturing option here, and if your body, for example, had some text extruded on the side of it, and you wanted to kind of walk over that with your mesh, if the text was, let's say, only 0.2 millimeters kind of extruded out of the body, and then you could put a defeaturing tolerance here, and let's say if the text was 0.2 millimeters, you can say 0.25, and then anything that is smaller than 0.25 millimeters, the mesh would kind of defeature it or delete it from the body and from the mesh. But since we do not want to have any defeaturing here, and we want to not have this warning every time we click update, I'm just going to put here this off. Okay, so you can update once more. Okay, and now we can see that our mesh is kind of limited to 10 millimeter elements on all the surfaces of the body. But since we left the behavior as soft here, okay, it just limits the maximum element size to 10 millimeters. If you have a lower sized element, a smaller element here, you can see it will allow that to kind of happen, and then transition that all the way to 10 millimeters and stop growing there. But if you change this behavior to hard, then it would force all the elements to be 10 millimeters, even these ones here, okay? So there would be kind of a rough transition from this face to this face, and you don't want that. So basically keep the behavior here as soft, okay? So what we would like to add now probably is an inflation layer. This is so we can capture the boundary effects of the flow on our body more accurately. So it is going to extrude a set of prism elements from each surface of the body that we select. There are several ways of doing this, and probably the easiest one is to let the program do the inflation as a program control, okay? So you would set the automatic inflation as program controlled, and then you would just like to make a few named selections, okay? So let's have our face selection tool, and you can click here and do a box select, okay? And then we're just going to zoom out a bit, and I'm just going to select like this, and this captured all of our body surfaces, okay? So the legs and all the surfaces of the body. And I'm going to right click and create a named selection called AMAD body, which is basically our simplified car here. So we have a new tab here, named selections, and here you have an option to exclude or include the faces in the program control inflation. So we would put this as include, okay? And while we're at it, we're going to create a bit more named selections, because we're going to need those later. So for this face here, we are going to name our selection a velocity inlet, because the Fluent solver will recognize this automatically and assign it a proper boundary conditions, which is going to be a velocity inlet. Same with the rear of our domain, which is going to be a pressure outlet.